Hello, everyone, and welcome to ThetaTalk number 3, AI Shield. Today, we are going to dive into AI and machine learning and how it transformed the fight against financial crime. I'm your host, Dagan Osovlansky, Chief Product Officer at ThetaRay, and I'm extremely pleased to host David Segev, Chief Scientist at ThetaRay. Hey. So let's move directly into the first question. We are talking quite a lot about machine learning, AI, but I'm not sure that everybody really understands how the world has changed from a rule-based system into an AI-based financial crime detection and the differences between supervised, unsupervised machine learning. David, as expert in that subject, can you shed some light and give us your insight on that?
Okay, yes. So let's start from the basis. So basically, there exist two main approaches in machine learning or AI: supervised approach and unsupervised. Let's say most of the AI is basically based on a supervised approach. So what is supervised approach? Maybe the best way to explain what it is by example. So say, for example, that you develop an algorithm that is going to find or object in pictures or in video. So usually in supervised learning or in machine learning in general, you have two phases, the training phase and usually or detection phase, depends on the task that the algorithm are going to perform. So during the training phase, say, for example, you are dealing with a object recognition algorithm. So during the training phase, you present that algorithm millions of pictures, for example. And those pictures will have objects that are well-defined and labeled. So you know exactly during the training phase what is inside the picture. And this is complete supervised learning. Another example would be, for example, learning from sign on the road or speed limitation and so on. Now, as soon as the training phase is done, the algorithm is going to perform a task. It can be, for example, image generation, like generative AI, for example. It can be decision-making. The car should turn left or turn right, for example. Or it can also be a classification. Is it that transaction is a fraud or is not a fraud? Okay. So this is, roughly speaking, the machine learning and a supervised approach. Now, to fight a financial crime, in many cases, supervised approach is not enough. So we need, in many cases, unsupervised and also semi-supervised approach. This is what we develop in ThetaRay, for example. Now, what is unsupervised approach? There, basically, the algorithm is not going to learn from known example. It's going to learn from the data itself, the transaction, for example, from the characteristics of the customers that are performing the transactions. And from those transactions, the algorithm are going to learn the structure in the data by itself. Now, and from there, let's say the structure will be a normal transaction. So from there, it can find anomalies and alerts and so on. In the case of semi-supervised approach, there you are given the algorithm some examples to learn from, examples of fraud, for example. And the algorithm is going to find in the future a very similar example of fraud. But at the same time, it will be also able to find, let's say, unknown cases. This is something that also unsupervised are able to do. Find unknown pattern of a money laundering alert and so on and so on.
So just to make sure, because sometimes it will sound different, actually semi-supervised is in a way superior to supervised and unsupervised because it's actually a combination of learning from what you know, but also detecting and identifying what we don't know.
Okay, so this, I wouldn't say superior, I would say different, in the sense that those type of learning really depend on the information available. Supervised, as I said, everything should be known, and this is in many cases not applicable to financial crime. And unsupervised are applied in cases where you don't know any example of a fraudulent transaction. But however, in most cases, you know something, but very few. You know very few examples of frauds or money laundering. So therefore, semi-supervised will be, I would say, the best approach in that sense.
So it will be optimal.
Yes, it will be optimal for financial crime detection, right? Mm-hmm.
Yeah, I just want to say that it's like the evidence in the market is that most use supervised, but then it's very limited, right? Because you have to know everything, but nobody knows everything.
Exactly. And specifically, if you are dealing with millions and millions of customers and transactions, you cannot have labels for all those transactions. It's impossible.
Okay. So I think maybe take us also a bit more about how the AI advanced in the recent years, because today everybody says AI and machine learning. It's become like the most common buzzword in the industry. But can you just share how it was evolved in the recent years and how it's transforming the landscape?
Yeah, so basically it's funny to say that, but machine learning exists for tens of years. In the 50s, 60s, and we have already neural network, for example. So after some point, they developed a random forest, gradient boosting, and many algorithms are also based on, for example, harmonic analysis and so on and so on. So, however, we had during the last, say, maybe 20 years, a very important development, technological development and scientific development. So, first of all, I would say the first development is related more to the data science field, where we had the capability or the possibility to store a huge amount of data. So basically, it started from there. As soon as you have a huge amount of data, now you need the tool, the algorithm, to analyze the data. And those algorithms have been developed, many of them have been developed, as I said, from the 60s and so on. But during the last 20 years, the algorithm became much more powerful to analyze a huge amount of data. And second, now those algorithms can run in the cloud. So everything can move now, the data itself stored, and the analysis of the data itself through using algorithms, everything can be made now in cloud. Now, I would say the third important development is related to open sources. Those open sources are, of course, by definition, accessible to the whole public. Everybody can actually develop his own code, publish it. It will be available and can be used by anybody. And this enable the democratization of algorithm development, data science, and so on and so on. So I would say those are three elements: data storage, cloud computing, open sources, are those I think main milestone in the development of these of the AI technology. Now, of course, at some point, the financial industry integrated those development, and say consider for example, transaction monitoring. Now, transaction monitoring is done also in cloud. The code can be also developed in the cloud, and of course used in cloud and so on. So there is much those facilities. There is it is much more easier now than in the past to perform this kind of task.
So maybe it's like combining. Yeah, the cloud is a major change, right? It's also allow us to deploy and provide the service in the cloud. But maybe before we are going into that, can you maybe speak a bit about how AI and machine learning helps financial institution, and actually how the development of theta array solution and algo was done in order to meet the purpose?
Okay, so I will start maybe from the existing systems. Those existing systems are in many cases rule-based, in the sense that you define for specific characteristics of the transaction, you define specific thresholds, and if, of course, the transaction passes that threshold, you have an alert.
It's a very specific scenario.
Yes, very usually, yes. So it is always based on knowledge, pre-knowledge of what is supposed to be in the future, let's say, the money laundering alert. So this is something simple. This is something that, in many cases, the offenders can easily know. And then the system can be easily bypassed. This is one of the problems of those systems. The second problem would be as soon as you define those rules, you may have a lot of false positive, meaning that in many cases you will be alerted, but when it is not, you are not supposed to be alerted. Now, the solution based on AI is much more powerful in the sense that, first of all, you do not rely on you don't have to rely on specific patterns and scenario. Meaning that those AI algorithms are learning from the data itself. As I said before, in case of unsupervised learning, the algorithm are going to define the hidden structure in the data. Are there some relationship that are hidden to your eyes or that a human cannot find? Are there some relationships between the characteristics of those transactions and so on? So this is something that the algorithm are now able, and the AI algorithm are able to find easily without any knowledge. Meaning, when I say without any knowledge, I mean by that I don't know specifically that a specific characteristic of the transaction is related to another one through a specific model. I don't assume anything. So therefore, it will be much more complicated for, say, an offender, since now it doesn't have any rules to bypass. It will be even complicated for an offender to understand how the algorithms are working. So therefore, those algorithms are much more, let's say, reliable. They are much more flexible, and they are able to also to analyze a huge amount of data. As I said before, since the data now is available in cloud, and so everything is much more, can be done on much larger scale.
Okay, and the cloud, as I said, it's a major benefits at the development level, at the deployment level, continuous learning. Can you tell us a bit about the story of how we got to financial crime? Because I know the company did many, many, many things, mostly successfully, but many things.
Mm-hmm. Well, let's at the very beginning say the algorithms were not supposed to work in the financial industry. So they were developed for different fields, for other fields like cyber. The goal was to find a cyber attack. In healthcare, for example, the goal was to find a reason of development of cancer and so on. But at some point, we moved to the financial industry. There, without a special modification of the algorithm, those algorithms, as I said before, they are very flexible in the sense that they can handle many types of data sets, no matter where they come from, and without major modification, let's say. Now, so at some point we moved to the financial industry, and using those algorithms and using the technology we talk about, cloud and so on, we were able to find those unknown cases of money laundering. So when I say unknown, I mean an unknown pattern. With in contrast to a rule-based approach, for example, where usually, as we explained before, we know beforehand what are the patterns we are looking for. And with the algorithm we developed, we, of course, can find a known pattern, but also unknown, okay? In cases where, of course, unsupervised algorithms are applied.
So we actually understood that we have something in hand that can help fight this huge problem, financial crime, like money laundering, terror financing, human trafficking, especially in this world that the scenarios will never catch all the bad guys. Maybe even to say the other way around. They catch very small portion of the bad guys.
Mm-hmm.
So it's like, it was like some sort of a game changer.
Yes, I will say. And I will also say that our system is even smarter than it was in the past, in the sense that it is able to integrate new information, a new pattern. Say, for example, using semi-supervised algorithm, you can integrate those new patterns or known cases of finance, of different type of crimes. You can integrate them in the system. It will learn those new patterns and then get smarter and smarter over time.
Which is interesting as chief scientist, and our solution is based on AI. That's and machine learning at the heart. How do we navigate the ethical and operational? I don't know if to call it problems, but there are challenges about AI in that space.
So the interesting part here is that, when you define rules, you need to understand the meaning of the characteristics of those, of course, of the meaning of the characteristics, the business meaning. Here, the algorithm doesn't have to know that, since they are analyzing numbers and they are looking for a hidden structure in those numbers. So everything can be anonymized. This is easy. So this is what basically we are doing. We keep the confidentiality of the customers. The transaction or the process of the transaction monitoring are secured. And of course, since the bank are not allowed to disclose any information on the customer, so we keep, of course, that confidentiality in the system.
So actually, the unsupervised approach that you don't determine what's good and what's right. So you don't tell the system, together with the fact that the algorithms doesn't know whether this field is the name, or this field is the address, or this field is the origin of the person. It's like very puristic and just ignore all the predetermined characteristics that actually does have ethical issues.
Exactly, yes, that's true. So I would say, so for example, as you explained, the algorithm doesn't know, say, if the customer that is doing the transaction is a woman or a man. Yet it has what's the color of that customer? Nothing. It doesn't have any bias from that point of view. So therefore, the unsupervised approach is very powerful here, in the sense that it doesn't look only at unknown patterns. The algorithm is going to look at pattern that has anything related to the type of the customer, the color, as I say, for example, or the sex of the customer, and so on. This is something that is very ethical and powerful, I would say.
Yeah. And it's also, I think, as you mentioned before, the cloud and the entire work on AI, and it's very collaborative.
Actually, I have a question to you. Do you have any examples of collaboration between ThetaTalk and financial institution? Is it done, and how, and what's the benefit of it?
So I think we work a lot with various types of customers. And the nice thing about it, we use our technology, but we have collaboration with our big customers that actually, I would say, from some level drive our technology to new places. And also we are sometimes co-developing or even getting their insight and their experience. And by the way, continuous learning from what happens at their side. So I think as a product that constantly being approved, we are using this collaboration. And as you know, we also have like new things that you actually developing, right? In the algo that are coming out of collaboration with this financial institution. And I think it's amazing. It's like a beneficial process to both sides. It's like very fruitful for both sides, and we see how it's evolve and how it takes the product, the solution to the next level, and also allow us to think on the next things, which you now need to think how we are going to do that. But this is, I think, very beneficial to both sides, and I think it's quite amazing to see how it's drive forwards.
So you would say that basically on the operational point of view, we get a lot of feedback basically from the customer themselves.
Yeah, and you actually, we created the feedback loop, right? How we get all this feedback and how we constantly improve and constantly make sure that the results are more accurate, right? So this is like, it's that constant aspect, but also developing new things, which is also extremely excited, that we constantly see how our algo can actually answer new problems and how we can develop some small changes to answer new pains and new issues, which is, I think, the beauty of the power of the algorithms. Maybe before we are wrapping up, looking forward, like, how do you anticipate this area to change, to develop, and how we see where the algorithms will go, what the solution will be, what is the new thing on the market?
Well, it's not easy to answer the question, but I would say let's start from, I would say, the last trend. We call it generative AI, as you probably know. Generative AI is a way of not only generating pictures or videos, but you can, for example, use it to help in translating a document or to analyze a document. Well, as you probably know, for example, you can ask a question. The algorithm understands the question, is going to answer the question. And so I think we will see in the near future the application of those generative AI algorithms in the field of financial crime. What I will expect also is still development of open sources. I cannot see any reason why we'll go back to what we saw in the past. So open sources, as I said, is very powerful. So for example, you will have now generative AI, LLM, large language modeling, are related to generative AI, and many have been developed in the last few years based on what we call the transformers. But now we see also the emergence of small language models. And those small language models also, in relation to open sources, can help a lot in the development of new tools, helping to fight financial crime. And still, I think the democratization of all those tools will maybe accelerate at some point. I will also see still the use of cloud services. when cloud services is also related to that democratization, and many people, as we explained before, can use those tools, and I cannot see any reason why we go back to on-site or on-prem development and so on. So I guess also cloud services will continue to help us in that field. We may also see, I'm not sure about it, but let's see. Maybe it will happen. Some kind of federate machine learning to fight financial crime, where you will see a collaboration, I will say, of financial institution toward the development of a new model, more generic model. And I think that the collaboration may help a lot in in fighting the financial crimes.
Yeah, I totally agree with you. And I think cloud and cloud providers like our partners, Microsoft Azure and others, I think that's probably one of the biggest enablers as to actually fighting financial crime in larger scales. That's definitely important. And I think other than thanking you for this amazing session, and I hope that I feel that I got smarter. I hope that everybody that will hear that will feel that they got smarter and understand a bit more this world and how it helps us and everybody to fight financial crime. So thank you very much, David. And
thank you very much,
see you all next time in the next ThetaTalk. Bye.
Bye-bye.